Hello everyone, in this video we're going to review Unit 8 Applications for Integration of the AP Calculus AB and BC. Alright, first we're going to talk about the error between two curves. When ds slides in, then we have this formula where y top and y bottom are written in terms of s. Alright. So in this situation, it's going to be the vertical rectangle, right? This one is the height. This one is the width. The height is the distance between the y top and y bottom. The width is ds, right? Now, similarly, dy slicing, you have this formula, where s right and s left are written in terms of y, right? And in this situation, you have the horizontal rectangle. Now, first, we need to sketch the region and draw a representative rectangle to be used in determining whether setting up with respect to ds or dy. Determine the slicing direction. Then find the volume of the slide, which will be the area of the face times the thickness. Determine the total volume by summing up the slides using the definite interval. Lastly, use the following templates to set up a definite interval. ds slicing, you're going to use this formula, where A of S is the area of the surface written in terms of S. dy slicing, you're going to use this formula, where A of y is the area of the face written in terms of y. Now, the volume of a solid of revolution. First, you need to sketch the region to be revolved and a representative rectangle, whose width can be used to determine whether iterating with ds or dy. Second, set up a definite interval after determining whether the slicing using ds or dy, so that the slicing is perpendicular to the axis of revolution. Lastly, identify the outside radius and the inside radius and use the appropriate template from below. Now, this method, ds slicing v equals pi times the interval from left s to right s radius squared ds. Now, dy slicing, we're going to use this formula. Now, let's run the washer method. You're going to use this formula if ds slicing and this formula if dy slicing. Now, let's take a look at the first example. The region enclosed by the x-axis, the line s equals 3, y equals square root of s, is rotated about the x-axis. What is the volume of the solid generated? Right? So we're gonna sketch the figure first, right? So it's gonna be something like this. Now this region right here rotate about the x-axis, so it becomes this solid right here, right? Now we can draw the circle. So the cross-section perpendicular to the x-axis is a circle, right? So you have the radius is distance from here to here, right? Alright, so the radius is changing, right? So it could be the function y equals square root of s, subtract this one y equals 0, right? So it could be square root of s subtract 0. It could be square root of s, right? Now you need to find the area of this circle. So the area is going to be pi r square, right? So it could be pi times this one square is going to be s, right? So the volume is going to be integral from left to right, right? So this is 0 and this one is 3, right? So it could be from 0 to 3 of this one, right? A of s ds, right? So it could be integral from 0 to 3 pi s ds, right? So it could be pi over 2s squared evaluated from 0 to 3, right? So it could be 9 pi over 2. So the answer should be C. Now let's move on to question 2. Find the area of the regions bounded by the lines x equals 0, x equals 2, y equals 0, and the curve y equals e to the s over 2. So we're going to sketch this one. 2, 0. And y equals 0, this is going to be the x-axis, y equals 0, right? The y-axis is going to be s equals 0, so keep that in mind. Alright, so we need to find the area of these regions right here, right? And it's very simple, right? So it could be integral from 0 to 2, right? Y top subtract y bottom, right? Y top is y equals e to the s over 2, right? So it could be e to the s over 2 subtract y bottom, which means y equals 0 right here, right? Then you just put the s right here, right? So it's going to be integral from 0 to 2 of e to the 1 over 2 s ds, right? Now keep in mind you have the formula antiderivative of e to the as plus b ds is going to be 1 over a e to the as plus b plus c, right? You have antiderivative of sine of a s plus b ds is going to be negative 1 over a of cosine of as plus b plus c, right? And the last one, antiderivative of cosine of as plus b ds is going to be 1 over a of sine of as plus b plus c, right? So keep that in mind. So in this situation, a equals 1/2, right? So if you take antiderivative of this one, it's going to be 1 over a, which means 2, right? E to the 1/2 s, right? Evaluated from 0 to 2, right? So substitute 2 for s, so it could be 2 times e to the 1/2 times 2, it could be 1, right? Subtract e to the 0, right? So it could be 2 times e minus 1, right? So it's going to be C. Now let's move on to question 3. The region bounded by the x-axis, the part of the graph of y equals cosine s between negative pi over 2 and pi over 2 is separated into two regions by the line s equals k. If the area of the regions for negative pi over 2 to k is 3 times the area of the regions for k to pi over 2, then what is the value of k, right? So basically, we just get the graph. The maximum of the cosine function is 1, right? This one is negative pi over 2, and this one is pi over 2, right? So it could be something like this. The line s equals k, so we don't know k. We just put k right here. Right, so this is the line s equals k. Now I call these regions A1, equal this is A2, right? So I have A1 equals 3A2, right? Now I need to calculate A1 first, right? So A1 is the row from negative pi over 2 to k, right? Y top subtract y bottom. Y top, which means y equals cosine s. Y bottom, y equals 0, right? So it could be cosine s ds, right? So it could be sine s evaluated from negative pi over 2 to k, right? So it could be sine k subtract sine of negative pi over 2 is negative 1, right? So you have negative of negative 1, it should be plus 1. Now A2 is the integral from k to pi over 2, right? Right here. Y top is right here. It could be y equals cosine s, right? Subtract y bottom, which means 0, right? So cosine s. So it could be sine s evaluated from k to pi over 2, right? So it could be sine of pi over 2 subtract sine of k, right? So it's going to be 1 minus sine of k, right? Now a1 equals 3a2. It's going to be sine of k plus 1 equals 3 times 1 minus sine of k, right? Now if you simplify this equation, it's going to be 4 sine of k equals 2. Then sine of k equals 1/2. Now take inverse side both sides, so you have k equals r sine of 1/2, right? And it's going to be pi over 6, right? So the answer must be C. Now let's move on to question 4. The base of a solid is the region in the first quadrant bounded by the y-axis. The graph of y equals inverse tangent of s. The horizontal line y equals 3. The vertical line x equals 1. For this solid, its cross-section perpendicular to the x-axis is a square. What is the volume of the solid? Right? So we're gonna sketch the figure first, right? And y equals inverse tangent of s. Let's look at the decimals. The red one is the y equals tangent s. The blue one is y equals inverse tangent of s. And these two guys right here reflect over y equals s. Remember, two functions are inverse of each other. They must be symmetric about the y equals s. Now we need to find the volume of the solid, right? So the cross-section perpendicular to the x-axis is a square, right? So it's gonna be something like this. Now you need to find the area of the square, right? So area of the square is the side length square, right? Now the side length, this guy is the side length, this guy is still the side length, right? Now the side length is the difference of this guy right here and y equals inverse tangent of s, right? So it's gonna be 3 minus inverse tangent of s squared, right? So the volume should be the integral from 0 to 1 right here of a of s ds, right? So it can be integral from 0 to 1 of 3 minus inverse tangent of s squared ds, right? So you're allowed to use the calculator. So you print up the calculator Add calculator. Now go to menu, calculus, interval right here, 0 to 1. You press enter. The answer is 6.6123. Now let's move on to question 5. The question comes from AB Calculus AB and BC question 1 in 2010 from B. Alright, in the figure above, the region R is the shaded regions in the first quadrant by the graph y equals 4 times ln 3 minus s. It's going to be right here. The horizontal line y equals z, so y equals z is right here. The vertical line s equals 2 is right here. Find the area of the region R. Alright, so basically the area of the region R is the integral from left to right, 0 to 2, right? Y top subtract y bottom. Y top is y equals z. Subtract y bottom is going to be 4 times ln of 3 minus s ds, right? So we're gonna bring up the calculator. I'm gonna copy this one over here and change the number. That's it. Then you press Ctrl Enter. It's gonna be 6.81665. Now question B. Find the volume of the solid generated when R is revolved about the horizontal line y equals 8. Now we're gonna sketch this region. So y equals 8 is gonna be right here. Alright, so if these regions revolve the line y equals 8, you're gonna use the washer method because you have a hole in the middle right here. Right? You have the volume of the solid is gonna be the integral from left s to right s, right? And then pi times the outside radius square, right? Subtract pi times the inside radius square, right? ds. V equals the integral from left to right, which means 0 to 2. Right? I put pi outside, right? Now the outside radius means the radius of the bigger circle, right? So it can be from here to here. Right? So it's gonna be y top subtract y bottom. Y top is y equal 8. Y bottom is right here, right? Now subtract the inner radius square. The inner radius is right here, which means the radius of the smaller circle, right? So it's gonna be y top subtract y bottom, which means 8 subtract 6, right? So we just print up the calculator. Then you press Ctrl Enter. It's gonna be 168.8. Now question C. The region R is the base of the solid. For this solid, its cross-section perpendicular to the x-axis is a square. Find the volume of the solid. Alright, so we go back over here. Now we just draw the cross-section. The cross-section perpendicular to the x-axis is a square, right? So it's going to be something like this. Alright, now you need to find the area of this square, right? So area equals the side length square, right? So the side length is the difference between the line y equals 6 and the bottom one right here, which means this one right here, right? Y top subtract y bottom, right? So you have 6 subtract this guy, right? And then you square, right? So the volume is going to be, alright, so you just print up the calculator. Press Ctrl Enter. It's going to be 26.2666. Now let's move on to question number 6. Calculator not allowed. This question comes from AP Calculus AB and BC question number 3 from B in 2011. Now the function f and g is given by f of s equals square root of s and g of s equals 6 minus s. Let R be the region bounded by the x-axis. The graph of f and g is shown in the figure above. Find the area of R, right? So since these two functions right here intersect at the points 4 and 2, right? So we just separate this region into two regions, right? The first one is going to be from 0 to 4, and the second one is going to be from 4 to 6, right? So the area of the region R is the interval from 0 to 4, right? Y top subtract y bottom. Y top is y equals f of s, right? Y bottom, which means y equals 0, the x-axis, right? So f of s is right here. It's going to be square root of s, right? ds plus the interval from 4 to 6. Y top is going to be g of s. It's going to be 6 minus s right here, right? So 6 minus s, subtract y bottom is going to be 0, right? ds. So it's going to be 2 over 3 s to the 3.5, right? Evaluated from 0 to 4 plus 6s minus 1/2 s squared evaluated from 4 to 6, right? Then we substitute 4 for s. So it's going to be 2 thirds 4 power of 3.5, right? Substitute 0 for s is going to be 0, right? Plus 6 times 6 minus 1/2 times 6 squared, right? Subtract 6 times 4 minus 1/2 times 4 squared, right? And if you simplify this one, it's going to be 22 over 3 is the final answer. Now you have the second way to calculate the error of the second one right here faster. Basically, we just calculate the error of this right triangle right here. Base times height divided by 2. The base is 2, right? The height is 2, right? So 2 times 2 divided by 2 is going to be 2, right? So this guy right here actually 2 over 3 times 8 plus 2. So the answer is 22 over 3. Now question B. The region R is the base of a solid. For each y value, y from 0 to 2, the cross-section of the solid taken perpendicular to the y-axis, be careful, okay, is a rectangle whose base lies in the region R and whose height is 2y. Write, but do not evaluate, an integral expression that gives the volume of the solid. Alright, So the cross-section is perpendicular to the y-axis. Now the area of the rectangle is going to be base times height, right? Now since the cross-section perpendicular to the y-axis, you need to convert every single thing in terms of y, right? Now the base right here is the difference between GOS and FOS, right? Right, subtract, left, keep that in mind. Alright, now GOS is right here, right? So we have y equals 6 minus s. You need to rewrite s in terms of y, right? So we have s equals 6 minus y, right? Now FOS right here is going to be y equals square root of s, square both sides, so you have y squared equals s, right? So s equals y squared, right? Now right subtract left, right, which means 6 minus y, right? So it could be 6 minus y, subtract left, left is going to be minus y squared right here, right? The height is given, it's going to be 2y, right? So the error is going to be base is going to be 6 minus y squared times 2y, right? And the bound is from 0 to 2 right here, right? Remember, you need to use the lower limit and upper limit of the y values. Keep that in mind. So I have volume equals the interval from 0 to 2 of 6 minus y squared times 2y dy, right? And I'm going to simplify this one. It's going to be interval from 0 to 2. Distribute this one is going to be 12y minus 2y squared minus 2y cubed dy, right? So it's going to be y times y squared over 2, right? Minus 2 over 3y cubed minus 2 over 4y to the 4 evaluated from 0 to 2, right? 12 divided by 2 is going to be 6. So you have 6y squared minus 2 over 3y cubed minus 1/2 y to the 4 evaluated from 0 to 2. Substitute 2 for y. So it could be 24 minus 16 over 3 minus 8. So it could be 16 minus 16 over 3, right? So it could be 32 over 3. Now let's move on to question C. There is a point P on the graph of f at which the line tangent to the graph of f is perpendicular to the graph of G. Find the coordinates of the point P. Alright, so suppose point P is right here, and then you have the tangent line is going to be like this. Now we need to find the coordinate of point P. In order to do that, we need to find the slope of the tangent line, right? Now, since this line and this line perpendicular, their slope product equals -1, right? The slope of this function is -1 right here, right? So m equals -1. The slope of this function right here, we just take derivative of this guy right here, right? So we have f prime of s equals 1 over 2 square root of s, right? This guy times this guy must be -1, right? So you have 1 over 2 square root of s times -1 equals -1, right? So it could be 1 over 2 square root of s equals 1, right? Then 2 square root of s equals 1, right? And then square root of s equals 1/2. square both sides, s equals 1 over 4. Right? Now substitute 1 over 4 for s into the graph fs right here. So you have f of 1 over 4 equals square root of 1 over 4. It's going to be 1/2, right? So the coordinate point P is 1 over 4, comma 1/2, right? Now let's move on to question 7. This question comes from AP Calculus AB and BC question 1 in 2007. Let R be the region in the first and the second quadrants bounded by the graph y equals 20 over 1 plus s squared and below by the horizontal line y equals 2. So basically we need to get this one. Now we need to find the intersection right here, and right here, right? This one is the y-intercept, right? We just let x equals 0, right? So when x equals 0, y equals 20. Now we need to find the intersection between the graph right here and the line y equals 2, right? So we just have 20 over 1 plus s squared equals 2. It's the same thing as 2 plus 2s squared equals 20, right? And then it's going to be 2s squared equals 18, right? And s squared equals 9. S equals plus and minus 3, right? So this one is negative 3. This one is 3, right? Now question 8, find the area of the region R, right? So basically we have the area is going to be the integral from negative 3 to 3, top subtract bottom, right? Top which means this guy, bottom which means y equals 2, right? So we have 20 over 1 plus s squared subtract 2, right? ds. Now you're gonna print up the calculator. Press Ctrl Enter to approximate the value, right? So it should be 37.9618. Now question B. Find the volume generated when the region R is rotated about the x-axis. Alright, so when this guy rotated about the x-axis, you see the hole right here. Right? So you need to use the Gaussian method, right? So the volume formula is given by pi times the integral from negative 3 to 3, right? Negative 3 to 3 of outside radius square minus inside radius square ds, right? Alright, so outside radius is the bigger radius. It's going to be from here to here, right? So y top subtract y bottom. Y top is y equals 20 over 1 plus s squared. Y bottom is y equals 0 right here, right? So it's going to be pi, the integral from negative 3 to 3 of 20 over 1 plus s squared all together square, right? Subtract y bottom. Y equals 0, so I don't need to write, right? Now the inside radius square is gonna be this guy right here, right? Y top is y equals 2, y bottom is y equals 0, right? So it could be 2 subtract 0 is gonna be 2, so square. And then you put the s right here, right? I'm gonna print up the calculator. Enter to approximate the value, right? So it's gonna be 1871.19. Now let's move on to question C. The region R is the base of the solid. For this solid, the cross-section perpendicular to the x-axis and semicircle. Find the volume of this solid, right? So we go back over here. The cross-section is the semicircle perpendicular to the x-axis, right? So it could be something like this. Alright. Now, you need to find the area of this semicircle, right? So in order to find the area of the semicircle, you need to find the diameter, right? So diameter is the distance from the function right here and the function right here, right? Top subtract the bottom, right? So it can be 20 over 1 plus s squared subtract 2, right? And then you need to find the radius. It could be 1/2 of this guy, right? 20 over 1 plus s squared minus 2, right? Alright, so now you need to find the error. So error is going to be 1/2 pi r squared, right? So substitute value 1/2 pi times this guy right here, 1/2 times 20 over 1 plus s squared minus 2 altogether squared. The volume of the solid is going to be the integral from -3 to 3 of a of s ds, right? So it can be integral from -3 to 3. A is right here. So I put pi over 2 in the front, right? 1/2 square, it turns out to be 1/4, right? So it should be pi over 8. And then I only have 20 over 1 plus s squared minus 2 altogether square ds, right? Now we're gonna print up the calculator. So I'm gonna use this one. Just copy this one down here. This one should be pi over 8. Integral from -3 to 3. 20 over 1 plus s squared minus 2. And then press Ctrl Enter. The answer approximately 174.268. Now let's move on to question 8. This question comes from AP Calculus AB and BC question number 6 from B in 2004. Let L be the line tangent to the graph of y equals s to the n, right? So the curve right here is y equals s to the n. At the point 1, 1 right here, where n greater than 1 as shown above. Find the integral from 0 to 1 s to the n ds in terms of n. So this one very simple, right? So it can be s to the n plus 1 over n plus 1 evaluated from 0 to 1. So it could be 1 over n plus 1, right? Now question B, let T be the triangular region bounded by the line L. The x-axis, the line s equals 1. Show that the area of T is 1 over 2n. Alright, so this region T is right here. Now, since line L tangent to the graph y equals s to the n at this point right here, we need to find the slope of line L, right? So the slope of line L is f prime of s, right? Evaluated at 1, 1, right? So take the derivative of this one is going to be n times s to the n minus 1. So substitute 1 for s is going to be n, right? Now we have the second way to find the slope of line L. It's going to be rise over run, right? Now rise is right here. It's going to be 1 right here. Run I'm gonna let this one be b, right? So this is b, right? Now this guy and this guy right here must be the same, right? So we have 1 over b equals n. So then b equals 1 over n, right? Now the area of the triangle T is 1/2 base times height, right? 1/2 times 1 over n times the height is 1 right here. So the answer is 1 over 2n. Then this one has been proved, right? Now question C. Let S be the region by the graph of y equal s to the n. The line L and the s-axis express the area of s in terms of n and determine the value of n that maximize the area of s, right? So the region S is right here. Now we know that the area of the region S is the interval from 0 to 1 of s to the n ds, right? The function right here. From 0 to 1 right here, right? The area under the curve. Subtract the area of the region T right here, right? The area of the triangle, which is you calculated in question B. It's gonna be 1 over 2n, right? But this one you calculated in question A. It's gonna be 1 over n plus 1, right? So it's gonna be 1 over n plus 1 subtract 1 over 2n, right? Now the question says we need to find the value of n that maximize the error of this one, right? So we just let this one as the function f of n. Now when it comes to minimum, maximum, increasing or decreasing of the function, we need to find the first derivative. So keep that in mind. So I have f prime of n is -1 times n plus 1 power of -2 minus -1 times 2n power of -2 times 2, right? So if we simplify this one, it's going to be -1 over n plus 1 all together square, right? Plus 2 over 2n all together square. Now we're gonna let this one equals to 0 to find the critical number, right? So f prime of n equal to 0 is the same thing as 2 over 2n all together square equals 1 over n plus 1 all together square, right? So it's gonna be 1 over 2n square equals 1 over n plus 1 all together square, right? The top 1 and 1 the same, the bottom must be the same. So you have 2n square equals n plus 1 all together square, right? Now take square root both sides. So we have n square root of 2 equals n plus 1, right? And n square root of 2 equals -n minus 1, right? So we just solve for n. So it will be n equals 1 over square root of 2 minus 1, right? And this one n equals -1 over square root of 2 minus 1, right? We look at the domain right here, n must be greater than 1, right? So we need to eliminate this guy right here because this one is negative number, right? So we have n equals 1 over square root of 2 minus 1. Radicalize this one, so it could be 1 times square root of 2 plus 1 over square root of 2 minus 1 times square root of 2 plus 1, right? So n equals square root of 2 plus 1, right? Now we're gonna sketch the side chart. We pick number 2 right here, right? Substitute over here. So we have -1 over 2 plus 1 is going to be 3 squared, it could be 9, right? Plus 2 over 2 times 2, it could be 4 squared, it could be 16, right? And of course, this one is positive, right? So this interval should be positive, this interval should be negative. Alright, so the function is increasing over this interval and decreasing over this interval, right? So we need to say that f prime of n changes sign from positive to negative at n equals root 2 plus 1. Then the only critical values is root 2 plus 1. Now let's move on to question 9. This question comes from AP Calculus AP and BC question 1 in 2008. Let R be the region bounded by the graphs of y equals sine of pi s and y equals s cubed minus 4s as shown in the figure above. So of course, you look at this one, the top one should be y equals sine of pi s, right? The bottom should be y equals s cubed minus 4s, right? Now find the error of the region R, right? So the error equals the interval from 0 to 2, right? Y top subtract y bottom, right? So we have sine of pi s subtract s cubed plus 4s. Be careful, right? You need to distribute negative 1, right? ds. And then you just print up the calculator. And then you press Ctrl Enter. It's gonna give you exact value 4, right? Now let's move on to question B. The horizontal line y equals negative 2 splits the region R into two parts. Right, but do not evaluate an integral expression for the error of the part of R that is below this horizontal line. Right, so the horizontal line is y equals negative 2 right here. Right, now you need to find the intersection right here, right? So basically you just equate this guy and this guy to find the intersection, right? So does that mean you have s cubed minus 4s equals negative 2, right? And then s cubed minus 4s plus 2 equals 0, right? So you just let f of s equals s cubed minus 4s plus 2 and you find the 0 of this one, right? So I'm going to bring up the calculator. I'm going to go to the home screen, hit graph. Now I'm going to press tab. I need to go to F1 right here. Now I need to change this one to s cubed minus 4s plus 2 and press enter. It's going to be right here, right? And you need to find two intersections. Since the s value right here is positive, right? So you have 3 zeros right here. You only pick 2 positive zeros right here, right? So I'm gonna press menu, analyze graph, and 0 right here. Go to the left, go to the right. You have the first 0. It's gonna be 0.593, right? Do exactly the same thing. Menu, number set, number 1. Go to the left, go to the right. You have the second 0 right here. So it's going to be 0.593 and 1.68, right? You have the error equals the interval form, right? Y top subtract y bottom. Y top is negative 2. Y bottom is s cubed minus 4s, right? So you subtract s cubed plus 4s ds, right? This one is the error of these regions right here. Now question C. The region R is the base of the solid. For this solid, its cross-section perpendicular to the x-axis is a square. Find the volume of this solid. Right. Now the cross-section perpendicular to the x-axis is a square. So you have a square right here. Alright. So error is sine square, because this one is the square, so it will be sine times sine, right? Sine is the distance from the top graph and the bottom graph, right? So it's gonna be top one is right here, sine pi s, subtract the bottom one is right here, right? So s cubed plus 4s all together square, right? And the interval from 0 to 2, right? So question C is going to be V equals the interval from 0 to 2 A of S ds, right? And it's going to be interval from 0 to 2 of sine pi s, subtract s cubed plus 4s square ds, right? Now we're going to bring up the calculator. Press the button right here. From 0 to 2 of sine pi s, and press Ctrl Enter. It's going to be 9.978. Now question D. The region R models the surface of a small pond. At all points in region R at a distance s from the y-axis, the depth of the water is given by h of s equals 3 minus s. Find the volume of the water in a pond. Alright, so this one is exactly the volume of the solid whose cross-section is the rectangle where the height is 3 minus s. The base is the difference between the top and the bottom graphs right here, right? So we're going to use exactly the same thing right here. Instead of the square right here, it's going to be the rectangle, right? So you have the height is right here, right? And the base is right here, right? The base is the distance between this graph right here and this graph right here, right? So you have V equals the interval from 0 to 2, right? Of the cross-section A of S ds, right? And it's going to be interval from 0 to 2. A of S is the area of the rectangles, right? Base times height. The base is the distance between this guy, so it's going to be sine of pi s subtract s cubed plus 4s times the height is going to be 3 minus s, and you put the s right here. And print up the calculator. I'm going to copy this one down over here and to change the number. Three minus s close parenthesis. Press Ctrl Enter. It's going to be 8.36995. Let's move on to the next section, particle motion. You need to understand the expression and mathematical translation. Alright, initial position, velocity, or acceleration of the particles. It means t equals 0. It's going to be s of 0, v of 0, or a of 0. Now the particle is at position s equals s1 at time t equals t1. So you have s of t1 equals s1, right? Now the particle is at rest means the velocity equals 0. Particles moving to the right means velocity greater than 0. Particle moving to the left means velocity less than 0. The average velocity of the particle on the interval a and b is to be 1 over b minus 8, interval from a to b of v of t dt, right? So it will be 1 over b minus a, antiderivative of v of t, which means s of t, right? This is position function, and it's going to be s of b minus s of a over b minus a. The instantaneous velocity of the particle at time t equals t1. It's going to be v of t equal s prime of t, right? Acceleration of the particle at time t equal t1 is going to be. Now next one, velocity of the particle is increasing. It means the derivative of the velocity is positive, right? So a of t equals v prime of t is greater than 0. Velocity of the particles is decreasing, v prime of t less than 0, right? The speed of the particles. The speed is the absolute value of the velocity. The speed of the particle is increasing or the particle is speeding up. It means v of t and a of t have the same sign. In other words, v of t times a of t is always positive, right? Now the speed of the particle is decreasing or the particle is slowing down. It tells us that v of t and a of t have the opposite sign, or v of t times a of t is always less than 0, right? The total distance traveled by the particle over the time interval a to b is to be interval from a to b of absolute value of v of t dt. Now, displacement of the particles or the net distance traveled by the particle over the time interval a to b is to be interval from a to b of v of t dt. Position of the particle at time t equals t2. So s of t2 equals the initial position s of t1 plus the interval from t1 to t2 v of t dt, right? Now the particle changes direction. This occurs when the velocity of the particles changes from positive to negative or from negative to positive. Particle is farthest to the left or to the right. You need to find the minimum or maximum value of s of t over the interval. Find the value of t where s prime of t1 equals v of t1 equals 0. The critical points of s. Consider the position of the particle at the critical points, and if the interval is closed at the endpoints of the interval. So basically, in this situation, we mostly use the candidate test, right? Alright, now let's move on to question 1. A particle moves along the x-axis with the velocity given by the v of t equal 3t squared plus 6t for t greater than or equal to 0. If the particle is at position s equal 2 at time t equals 0, what is the position of the particle at time t equals 1, right? So you have the formula s of t2 equals s of t1 plus the interval from t1 to t2 v of t dt, right? So it's going to be s of 1 equals s of 0, right? This one is t1. This one is t2, right? Plus the interval from 0 to 1 v of t dt, right? So s of 0 equals 2 right here, right? So you have 2 plus interval from 0 to 1 v of t given this one. And then it's going to be 2 plus t cubed plus 3t squared evaluated from 0 to 1, right? So it could be 2 plus, substitute 1 for t, right? So it could be 1 plus 3, right? And the answer is going to be 6. So, answer choice B. Now let's move on to question 2. A particle travels in a straight line with a constant acceleration of 3 meters per second per second. If the velocity of the particle is 10 meters per second at time t equals 2 seconds, how far does the particle travel during the time interval when its velocity increases from 4 meters per second to 10 meters per second, right? The question asks you how far, which means position, right? S of t. In order to find this one, you need v of t, right? And in order to find v of t, you need a of t, right? So you have the particle travels in a straight line with a constant acceleration 3 meters per second, right? So we have a of t equals 3. Then v of t equals antiderivative of a of t, right? Which means 3 dt, right? And it's gonna be 3t plus c, right? And we use the condition right here, right? So we have v of 2 equals 10. Substitute over here to solve for c, right? So you have 10 equals 3 times 2 plus c, then c equals 4, right? So v of t equals 3t plus 4, right? Now, we given the velocities increases from 4 meters per second to 10 meters per second. Right? We substitute over here, we solve for t, right? So we have v of t equals 4. Then you have 3t plus 4 equals 4. And then t equals 0, right? V of t equals 10. Then 3t plus 10 equals 4. Then t equals 2, right? Then, in order to find s of t, we need to take antiderivative of v of t, right? So s of t equals antiderivative of v of t dt, right? And then we have the interval from 0 to 2, so we put 0 to 2 right here, right? Now, the question says how fast does the particle travel during the time interval, right? Asks you to find the total distance, so you need to put the absolute value of v of t right here. Alright, so it's going to be interval from 0 to 2, absolute value of 3t plus 4 dt, right? So it's going to be 3 over 2 t squared plus 4 t evaluated from 0 to 2, right? So it could be 3 over 2 times 4 plus 4 times 2, and it's gonna be 6 plus 8, and it's gonna be 14, right? So the answer must be B. Question 3. If the position of the particles on the x-axis at time t equals negative 5t squared, then the average velocity of the particles for 0 to 3 is, so we have the average velocity is s of 3 minus s of 0 over 3 minus 0, right? Now the position is s of t equals negative 5t squared, right? So we have negative 5 times 3 squared minus negative 5 times 0 squared over 3, right? So it could be negative 45 over 3. It could be negative 15, right? The answer must be C. Now let's move on to question 4. The table below gives selected values of the velocity v of t of a particle moving along the x-axis at time t equals 0. The particle is at origin. Which of the following could be the graph of the position, so s of t, of the particle for 0 to 4, right? So we look at this one, we see that the first order pair right here tells us that v of 0 equals negative 1, which is less than 0, right? So remember, velocity is the first derivative of the position function, or it's going to be the slope of the tangent line, right? At s equals 0, right? So right at s equals 0 right here, the velocity is negative, right? So we draw the tangent line right here. We use the Christmas tree trick. If the line is going up, the slope is positive. Line is going down, slope negative. line horizontal slope is 0, line is vertical slope is undefined, right? Now tangent lines going up, so slope is positive. Tangent lines right here going up, the slope is positive, right? This one tangent lines going down, so the slope is negative. Tangent lines going up, the slope is positive. Tangent lines going down, the slope is negative, right? Now we need this one to be negative, right? So we need to eliminate A, B, and D, right? We're going to use the second order pair right here. So we have V of 1 equals 2. So it tells us that the position function is increasing at t equals 1, right? So at t equals 1, it's going to be right here, and it's going to be right here. This guy is increasing because the slope is positive, right? This guy is either decreasing or constant, because the slope right here could be 0, right? It could be horizontal tangent line, right? So you need to eliminate E. Now we're going to check the remaining order pair. V of 2 equals 3. So it's going to be positive. The function is increasing at t equals 2. 2 right here, yes, it's increasing. T equals 3, so you have V of 3 equals 0, right? So 3 right here. You see the horizontal tangent line right here, right? The slope is 0, right? And the last one, V of 4 equals negative 4, which is negative. The function is decreasing, yes. At 4 right here, the function is decreasing, the slope is negative, right? So the answer choice C is correct. Now let's move on to question 5. A particle moves along the x-axis so that at any time t greater than or equal to 0, its velocity is given by v of t equals 3 plus 4.1 cosine 0.9t. What is the acceleration of the particle at time t equals 4? So you know that acceleration is the first derivative of the velocity, right? So it's going to be 4.1 times 0.9 sine of 0.9 t. Don't forget to have the negative side right here, right? So A of 4 equals negative 4.1 times 0.9 sine of 0.9 times 4, right? So we're going to print up the calculator. Make sure your calculator in the radian mode. So you're going to check this guy right here. It should be radian, right? So you have negative 4.1 times 0.9. And then check his side right here of 0.9 times 4. It could be 3.6, right? And then press Control Enter. It's going to give you approximate value 1.6329, right? So you're gonna grab this one. The answer is C. Let's move on to question 6. Two runners A and B run on a straight track for t from 0 to 10 seconds. The graph below, which consists of two line segments, shows the velocity in meters per second of runner A. The velocity in meters per second of the runner B is given by the function v divided by v of t equals 24t over 2t plus 3, right? Question A. Find the velocity of runner A and the velocity of runner B at time t equals 2. So t equals 2 right here, right? This point is on this line, right? So we need to find the equation of this line first, right? So we have v of t equals ms plus b, right? The graph of this function past origin, so b equals 0, right? So it's going to be ms only, right? Now we're going to use rise over run to find the slope, right? So rise is 10, run is 3, right? So the slope is 10 over 3, right? So V of t equals 10 over 3t, right? So the value of s right here in this situation is going to be t, right? Velocity of the runner A is 10 over 3 times 2, right? Because you can substitute 2 for t into this function, right? So it's going to be 20 over 3 meter per second, right? The velocity of runner B is, use this function right here, right? So you have 24 times 2 over 2 times 2 plus 3 is going to be 48 over 7 meter per second, right? Now question B. Find the acceleration of runner A and the acceleration of runner B at time t=2. You know that acceleration is the first derivative of the velocity, right? So I have A of A. It's going to be V prime of A at 2, right? So you put 2 right here, right? Now take derivative of this one. It's going to be 10 over 3, right? So it could be 10 over 3 meter per second square, right? Now acceleration of runner B at t equals 2 is going to be V prime of B at 2, right? Now you need to take derivative of this guy right here. So you're going to use the quotient rule, right? So we have 24 times 2t plus 3, right? Minus 2 times 24t over 2t plus 3 all together square, right? So I have 24 times 2 times 2 plus 3 minus 2 times 24 times 2 over 2 times 2 plus 3 all together square, right? So it's going to be 24 times 2 times 2, it could be 4, 4 plus 3, it could be 7, minus 96, right, over 49, right? 24 times 7 is going to be 168, minus 96 over 49. Alright, so it's going to be 72 over 49 meter per second square. Now question C. Find the total distance run by runner A and total distance run by runner B over the interval 0 to 10 seconds. We have the total distance of runner A equals the interval from 0 to 10 of absolute value of V of t of A dt, right? So we look at the graph right here. We just calculate the error under the curve, right? So this one is the triangle and this one right here is the rectangle, right? So it could be 3 times 10 divided by 2. Plus this guy right here is 7, right? This guy right here is 10, right? So 10 times 7. The answer is 85 meter, right? Now, distance the runner B travel. It's going to be interval from 0 to 10, absolute value of V, B of t dt, right? So, we have the interval from 0 to 10 of 24t over 2t plus 3 absolute value of this one dt, right? So we're gonna bring up the calculator. Alright, so we're gonna hit this button right here, pick the interval right here. Interval from 0 to 10 of absolute value. So we hit the button right here, pick the absolute value side. Hit this button, put a fraction. Control, enter. It's gonna be 83.336, right? Now let's move on to question 7. A particle moves along the y-axis with velocity given by this guy for t greater than or equal to 0. In which direction, up or down, is the particle moving at time t equals 1.5? So we have v of 1.5 equals 1.5 times sine of 1.5 altogether square, right? And you're gonna print up the calculator. You have 1.5 times check sine of 1.5 square. Press enter. It's gonna be 1.167, which is greater than 0, right? So if it's greater than 0, it tells us that the particle moving up, right? Now question B. Find the acceleration of the particle at t equals 1.5, right? So we have a of 1.5 equals v prime of 1.5, right? So we're gonna print up the calculator. We just store the function, right? So you're gonna press v of t. Then you're gonna press control this button right here. Then it's gonna be t times sine of t square. Alright, you press enter, done. Now keep in mind you need to put the multiplication between t and sine. If you don't do that, the calculator won't understand that, right? Now you need to calculate v prime of 1.5, right? So you're gonna press the button right here, this guy right here. Alright, so we put t, variable t, right? Right here you just put v of t. Now you're gonna press control equals and put the line right here. Press t equals 1.5. You press enter. It's gonna give you the values negative 2.0487. Is the velocity of the particle increasing at time t equals 1.5? This guy less than 0. So you need to say no, because a of 1.5 less than 0, right? Question C. Given that y of t is the position of the particle at time t and that y of 0 equals 3, we need to find y of 2, which means y of 2 equals initial position is going to be y of 0 plus the interval from 0 to 2, right? This guy right here and this guy right here tells us that the interval from 0 to 2 of v of t dt, right? So it could be y of 0 is going to be 3 plus the interval from 0 to 2. V of t is going to be t times sine of t square dt, right? So we're going to print up the calculator. Now we already stored the function v of t, right? So now we just press this button right here Then we're gonna pick the interval. It's gonna be from 0 to 2 of v of t dt. Alright, and you press enter. Now you need to convert this value into the decimal. You press Ctrl enter. It's gonna give you 0.826822, and then you need to add 3. Press enter. It's gonna be 3.8268, right? Now question D. Find the total distance traveled by the particle from t equals 0 to t equals 2. Right? So the total distance equals the interval from 0 to absolute value of v of t dt. Right? So we're gonna bring up the calculator right here. We just copy this one down over here. Alright? We just put this guy inside the absolute value sign, right? So we just highlight this one, press the button right here, hit this guy right here, right? And then press Ctrl enter. It's gonna be 1.17318, right? Now let's move on to the last topic, rate in and rate out problems. Question 1. A popular 24-hour health club has 29 people using its facility at time t equals 0 during the time interval from 0 to 20 hours. People entering the health club at a rate given by the function right here. During the same time period, people leaving the health club at the rate of this guy. Question A. Is the number of people in the facility increasing or decreasing at time t equals 11? This one is entering, right? And this one is leaving, right? Now we need to calculate E of 11 and then L of 11, right? Now we need to print up the calculator. We need to store the function. First, we need to store E of t. Press Ctrl the button right here. Then we're gonna input negative 0.018 t squared plus 11, and then press enter, right? And then we need to store the leaving function, right? So L of t equals this guy, right? So we need to press Ctrl this button right here and then type 0.013 t squared minus 0.25 t plus 8, and then press enter. Now we need to calculate E of 11, right? So we have E parenthesis 11. Press enter. It's gonna be right here. And L of 11. Press enter. It's gonna be right here, right? So E of 11 is 8.822, and L of 11 is gonna be 6.823, right? From these two guys, we can conclude that E of 11 is greater than L of 11, right? It tells us that the number of people in the facility is increasing. Now let's move on to question B. To the nearest whole number, how many people are in the health club at time t equals 20? Alright, so we have P of 20 equals P of 0, right? This one is the initial one, plus the interval from 0 to 20 of E of t dt, right? This one is the number of people entering the building. Subtract the number of people leaving the building, right? We look at this one right here. At t equals 0, we only have 29 people, right? So we're gonna print up the calculator. We have 29 plus, hit the button right here, and then press this guy. The interval from 0 to 20 of e of t dt. Then you're gonna subtract L of t, right? Because both functions have the same upper bound and lower bounds, right? And then you just press Control Enter. It's gonna give you 56.33, but you need to round to the nearest whole number, right? So the answer is approximately 56 people. Now question C. At what time t, for t from 0 to 20, is the amount of people in the health club maximum? Now we need to use the candidate test, right? This one is the closed interval 0 to 20. Now we have the function p of t is p of 0 is going to be 29 plus the interval from 0 to t e of s ds, right? Minus the interval from 0 to t of l of s ds, right? Now, in order to find the maximum value, we need to take the derivative of function p of t, right? So you have p prime of t equal derivative of this one equals 0. Derivative of this one, you just print t over here, right? So you have e of t minus l of t, right? Print this one over here. Now, you need to let this one equal to 0. So it's the same thing as e of t equals l of t, right? Now you need to find the intersection between e of t and l of t, right? So you're gonna print up the calculator. You're gonna press home screen, go to the graph, negative 0.018 s square plus 11. Press enter. You couldn't see the graph, so you need to go to menu, window zoom, window setting right here. Now the s value is 0 to 20. The y values is going to be negative 30 to 30. Press enter. It's going to be right here. Right. Now we do exactly the same thing for the second function, right? So we're gonna press tab 0.013 s square minus 0.25 s plus 8. Press enter. It's gonna be right here. Alright, so we're gonna find the intersection between this guy and this guy, right? So we're gonna press menu, analyze graph, and intersection right here. Go to the left, go to the right, the answer is right here. 14.7, right? Now we're gonna use the candidate test. So we get the table. Now we're gonna place t equals 0, t equals 14.7, and t equals 20, right? At t equals 0, this guy equals 0, this one equals 0, you have 29, right? T equals 14.7, you're gonna plug it in over here. So we're gonna print up the calculator. Press home screen, go to calculate. Now you have 29 plus the interval from 0 to 14.7, right? And I press enter. It's gonna be 67.2872. Now we need to find P of 20. So we print up the calculator again. P of 20 is right here, 56.333, right? Now the maximum value is this guy right here, right? So we need to say the number of people is maximum at t equals 14.7 hours. Now let's move on to question D. If the health club has less than 10 people using its facility, the owner will serve everyone a special health drink. Set up but do not solve an inequality involving one or more intervals that could be used to find the time h when the number of people in health club is less than or equal to 10. Alright, so this one very simple. We just use the equation right here. Alright, we just replace t right here with h right here, right? So we have p of h equals 29 plus the interval from 0 to h. E of t subtract L of t dt, and this guy must be less than or equal to 10. That's it, right? Question 2 right here, similar to question 1. I'm gonna leave this one for you to practice. I just give you the answer. The answer for question A is 510.1599 cos. The answer for question B is e prime of 5 is negative 1.6273. Now question C. The answer is 665.103 cos. Now question D. The maximum number of cars in the parking garage is 665 cars. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in